The labor rate to install aluminum-clad metal-clad cable assemblies for 4 number 4/0 copper is $1.50 to $2.0 per foot. The labor rate to install 4 number 250 kilocircular mils aluminum is $2.25 to $3.0 per foot. These rates are based on the 2023 means electrical cost data. For budget purposes, if you do not have access to a current means guide, you can use the following labor rate. For an overhead application 15 feet above finished floor, it is $2.50 per foot. This rate is a general estimate and may vary depending on the specific project conditions and location. To elaborate on electrical installation cost data, it's crucial to understand the various factors influencing labor rates beyond just the size and type of cable. These factors include the complexity of the installation environment, the height at which the work is performed, and regional labor costs. Breaking down these factors, firstly, the complexity of the installation environment plays a significant role. If the cable needs to be installed in a congested area with numerous obstacles such as pipes, ducts, or other cables, the installation will take longer and require more skill. This increased difficulty directly translates to a higher labor rate. For instance, running cable through tight spaces or around sharp corners necessitates careful planning and execution to avoid damaging the cable or creating safety hazards. Secondly, the height at which the work is performed impacts the labor rate. Working at elevated heights, such as 15 feet above the finished floor, requires additional safety precautions and equipment such as ladders, scaffolding, or lift. These added measures increase the time and effort required for the installation, thus driving up the labor costs. Furthermore, working at height can be more physically demanding, requiring workers to take more frequent breaks, which further extends the overall installation time. Thirdly, regional labor costs are a significant determinant of the overall labor rate. Labor rates vary widely across different geographic regions due to factors such as the local cost of living, the supply and demand of skilled electricians, and union versus non-union labor. Areas with a high cost of living and a strong demand for electricians typically have higher labor rates compared to areas with lower cost of living and a larger pool of available workers. In addition to these primary factors, several other considerations can influence labor rates. These include the need for specialized tools or equipment, the presence of hazardous materials, and the requirement for permits or inspections. Specialized tools or equipment, such as cable pullers or benders, may be necessary for certain installations, adding to the overall cost. The presence of hazardous materials, such as asbestos or lead, requires additional safety precautions and disposal procedures, which can significantly increase labor costs. The requirement for permits or inspections can also add to the overall cost, as these processes involve administrative fees and potential delays. Now, let's delve deeper into the specific cost data provided for aluminum-clad metal-clad cable installations. The labor rate for installing 4 number 4/0 copper cable ranges from $1.50 to $2.0 per foot, while the rate for installing 4 number 250 kilocircular mils aluminum cable ranges from $2.25 to $3.0 per foot. These rates are based on the 2023 means electrical cost data, which is a widely recognized and respected source of cost information for the construction industry. The means electrical cost data provides detailed breakdowns of labor, material, and equipment costs for various electrical tasks, allowing contractors and estimators to develop accurate and competitive bids. When using the means electrical cost data, it's important to understand the assumptions and limitations of the data. The data is based on average conditions and may not reflect the specific circumstances of every project. Therefore, it's crucial to adjust the data to account for any unique factors that may affect the cost of the installation. For example, if the project involves working in a particularly challenging environment or requires specialized tools or equipment, the labor rate should be adjusted accordingly. For budget purposes, a general estimate of $2.50 per foot can be used for overhead applications 15 feet above the finished floor. This rate provides a reasonable starting point for estimating the cost of the installation, but it should be refined as more information becomes available. It's important to remember that this rate is a general estimate and may vary depending on the specific project conditions and location. To further refine the cost estimate, consider the following factors. Firstly, the length of the cable run. Longer cable runs will require more labor and materials, increasing the overall cost. Secondly, the number of bends or turns in the cable run. More bends or turns will require more time and effort to install, increasing the labor cost. Thirdly, the type of supporting structure. The type of supporting structure, such as cable trays or conduits, will affect the material and labor costs. Fourthly, the availability of access. Limited access to the installation area will increase the time and effort required for the installation, increasing the labor cost. Finally, the experience and skill of the electrician. More experienced and skilled electricians will be able to complete the installation more quickly and efficiently, reducing the labor cost. In addition to the labor rates provided, it's also important to consider the material costs associated with the installation. The material costs will depend on the type and size of cable, as well as the cost of any necessary connectors, fittings, and supporting hardware. To obtain accurate material costs, consult with local electrical suppliers or refer to current price lists. When estimating the overall cost of the installation, it's also important to include a contingency for unforeseen expenses. Unforeseen expenses can arise due to unexpected site conditions, changes in the project scope, or delays in material delivery. A contingency of 5% to 10% is typically recommended to cover these potential costs. To summarize, estimating the labor rate for installing aluminum-clad metal-clad cable assemblies requires careful consideration of various factors, including the complexity of the installation environment, the height at which the work is performed, regional labor costs, and the specific project conditions. By using reliable cost data, such as the means electrical cost data, and adjusting for any unique factors, contractors and estimators can develop accurate and competitive bids. Remember to consider the material costs, add a contingency for unforeseen expenses, and consult with local electrical suppliers to obtain the most up-to-date information. Furthermore, let's explore the different types of aluminum-clad metal-clad cables available and their specific applications. Aluminum-clad metal-clad cable, often referred to as MC cable, is a type of electrical cable that consists of insulated conductors encased in a flexible metallic sheath made of aluminum. This type of cable is widely used in commercial, industrial, and residential buildings for power distribution, lighting, and control circuits. The aluminum sheath provides mechanical protection to the conductors and also serves as a grounding path. MC cable is available in various sizes, conductor types, and insulation materials to suit different applications. The size of the cable is determined by the ampacity requirements of the circuit, while the conductor type and insulation material are selected based on the voltage, temperature, and environmental conditions. Common conductor types include copper and aluminum, while insulation materials include polyvinyl chloride, cross-linked polyethylene, and nylon. One of the key advantages of MC cable is its flexibility, which allows it to be easily routed through walls, ceilings, and floors. This flexibility also makes it easier to install in tight spaces or around obstacles. Another advantage of MC cable is its durability, which makes it resistant to damage from impact, abrasion, and moisture. MC cable is also relatively easy to terminate, requiring only simple tools and techniques. When selecting MC cable for a specific application, it's important to consider the following factors. Firstly, the ampacity requirements of the circuit. The cable must be sized to handle the maximum current that the circuit will carry. Secondly, the voltage rating of the cable. The cable must be rated for the voltage of the circuit. Thirdly, the temperature rating of the cable. The cable must be rated for the maximum temperature that it will be exposed to. Fourthly, the environmental conditions. The cable must be suitable for the environmental conditions such as moisture, chemicals, or extreme temperatures. Finally, the applicable codes and standards. The cable must comply with all applicable codes and standards such as the National Electrical Code, or NEC. In addition to selecting the appropriate type of MC cable, It's also important to follow proper installation practices to ensure a safe and reliable electrical system. Proper installation practices include properly supporting the cable, avoiding sharp bends or kinks, and making secure terminations. The cable should be supported at intervals specified by the NEC, typically every 6 feet for horizontal runs and every 10 feet for vertical runs. Sharp bends or kinks can damage the cable and reduce its ampacity. Terminations should be made using approved connectors and techniques to ensure a secure and reliable connection. When working with MC cable, it's also important to follow safety precautions to prevent electrical shock or other hazards. Always to energize the circuit before working on the cable. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Inspect the cable for damage before installation. Finally, test the circuit after installation to ensure that it is working properly. Furthermore, let's discuss the differences between copper and aluminum conductors in MC cable and their respective advantages and disadvantages. Copper and aluminum are the two most common conductor materials used in electrical cables, including MC cable. Each material has its own unique properties that make it suitable for different applications. Copper is a highly conductive material with excellent ductility and corrosion resistance. It is also relatively strong and durable. These properties make copper a popular choice for electrical conductors, especially in applications where high reliability and performance are required. However, copper is also a relatively expensive material, which can increase the overall cost of the cable. Aluminum is a lighter and less expensive material than copper. It also has good conductivity, although it is not as conductive as copper. Aluminum is also more susceptible to corrosion than copper, but this can be mitigated by using appropriate alloys and coatings. Aluminum conductors are often used in large-size cables, such as those used for service entrances or feeders, where the weight and cost savings can be significant. When comparing copper and aluminum conductors, it's important to consider the following factors. Firstly, the conductivity. Copper has higher conductivity than aluminum, meaning that it can carry more current for a given size. Secondly, the weight. Aluminum is lighter than copper, which can be an advantage in applications where weight is a concern. Thirdly, the cost. Aluminum is less expensive than copper, which can be a significant factor in large projects. Fourthly, the corrosion resistance. Copper has better corrosion resistance than aluminum, but aluminum can be protected with appropriate alloys and coatings. Finally, the mechanical strength. Copper is stronger and more durable than aluminum. In general, copper conductors are preferred for smaller size cables and applications where high reliability and performance are required. Aluminum conductors are often used in larger size cables where weight and cost savings are more important. When using aluminum conductors, it's important to use connectors and terminations that are specifically designed for aluminum to prevent corrosion and ensure reliable connection. These connectors typically have a special coating or grease that helps to prevent oxidation of the aluminum. It's also important to follow proper installation practices, such as tightening the connectors to the specified torque to ensure a secure and reliable connection. In addition to the conductor material, the insulation material used in MC cable also plays a critical role in its performance and safety. The insulation material provides electrical insulation between the conductors and the metallic sheath, preventing short circuits and ground faults. Common insulation materials include polyvinyl chloride, cross-linked polyethylene, and nylon. Polyvinyl chloride, or PVC, is a thermoplastic polymer that is widely used as an insulation material due to its low cost, flexibility, and resistance to moisture and chemicals. PVC insulation is typically used in general-purpose applications where the temperature and environmental conditions are not extreme. Cross-linked polyethylene, or XLPE, is a thermosetting polymer that offers improved thermal and electrical properties compared to PVC. XLPE insulation is more resistant to heat, abrasion, and chemicals, making it suitable for higher temperature applications and harsh environments. Nylon is a polyamide polymer that is often used as a jacket or coating over other insulation materials, such as PVC or XLPE. Nylon provides additional protection against abrasion, moisture, and chemicals. When selecting the insulation material for an MC cable, it's important to consider the following factors. Firstly, the voltage rating. The insulation material must be rated for the voltage of the circuit. Secondly, the temperature rating. The insulation material must be rated for the maximum temperature that it will be exposed to. Thirdly, the environmental conditions. The insulation material must be suitable for the environmental conditions such as moisture, chemicals, or extreme temperatures. Finally, the applicable codes and standards. The insulation material must comply with all applicable codes and standards, such as the NEC. In summary, selecting the appropriate type of MC cable for a specific application requires careful consideration of various factors, including the conductor material, insulation material, size, and ampacity. By understanding the properties and advantages of different materials and following proper installation practices, you can ensure a safe and reliable electrical system. Additionally, always consult with a qualified electrician or electrical engineer to determine the best type of MC cable for your specific application. They can assess the specific requirements of your project and recommend the appropriate cable size, conductor material, insulation material, and installation methods to ensure a safe and reliable electrical system that complies with all applicable codes and standards. They can also help you to estimate the labor and material costs associated with the installation, providing you with a more accurate and comprehensive budget for your project. Furthermore, staying up to date with the latest industry trends and technologies in electrical cable design and installation can help you to make informed decisions and optimize the performance and efficiency of your electrical systems. This includes keeping abreast of new materials, manufacturing processes, and installation techniques that can improve the reliability, durability, and cost-effectiveness of electrical cables. For example, advancements in nanotechnology have led to the development of new insulation materials with enhanced thermal and electrical properties, allowing for smaller and lighter cables with increased ampacity. Similarly, new installation techniques, such as prefabrication and modular construction, can significantly reduce the labor costs and installation time associated with electrical cable installations. By embracing these advancements, you can improve the overall performance and sustainability of your electrical systems and reduce your environmental impact. In addition to staying up to date with the latest technologies, it's also important to participate in continuing education and professional development opportunities to enhance your knowledge and skills in electrical cable design and installation. This can include attending industry conferences, workshops, and training courses, as well as pursuing certifications and licenses that demonstrate your expertise in the field. By investing in your professional development, you can stay ahead of the curve and provide your clients with the highest quality electrical services. Finally, remember that safety should always be the top priority when working with electrical cables. Always follow proper safety procedures and use appropriate personal protective equipment to prevent electrical shock, burns, and other injuries. If you are not qualified or experienced in working with electrical cables, it's best to hire a licensed electrician to perform the work. They have the knowledge, skills, and equipment necessary to safely and effectively install and maintain electrical cables. By prioritizing safety, you can protect yourself, your colleagues, and the public from the hazards associated with electricity. In conclusion, understanding the labor rates, material costs, and installation practices associated with aluminum-clad metal-clad cable assemblies is essential for planning and executing successful electrical projects. By considering the various factors that influence these costs and following proper safety procedures, you can ensure a safe, reliable, and cost-effective electrical system that meets your specific needs and requirements.